In this video, I'll be explaining my project code that I've done for summer training. So this you can see this is my code. It is for the sentiment analysis. So these are the libraries that I've used. Pandas is used to provide data structures and analysis. Sys library is used for command line arguments. If you want to give input through command line, then sys is used. RE stands for regular expression. It has a small part in this project. NLTK and sklearn are the most important libraries, and I'll be explaining what they do later onwards. So initially I initialized a variable. It is empty. So in this variable I'll be passing a sentence through command line. So this is the code for that. So now I created an empty list and appended the sentence in the list. Now the trained data has been downloaded through web. This training data is required in different types. What I need is sentiment values and the sentence. Sentiment values will be in the format of ones or zeros, and sentence will be corresponding. So now I created a variable stemmer. In it I passed Porter stemmer. Porter stemmer is a feature of NLTK. Here you can see NLTK.stemmer Porter. So what it does is it removes the affixes like ness, ed, which are used with words. So what we want are the main words, not their affixes. So Porter stemmer will be doing that job. So this function stem token function, what this does is it will create a list, and that list will contain words without affixes. So this function will be used later onwards. Now this is another function, tokenize. Tokenize is to create some tokens. Here you can see re.sub is used. All the letters and stop words and punctuations will be removed here. Then we'll tokenize the sentence and then stem the sentence using the function that we created previously. So it will return stems. Alright. So now vectorizer is another variable. In it I passed count vectorizer. Count vectorizer is now a feature of sklearn. So what it does is it removes unnecessary data and performs some other operations which I'll show. So count vectorizer has many attributes. So I'll be using these 5 attributes which I require. Analyzer, I'll pass word in it since I require words. In tokenizer, I'll pass the function tokenize since it's performing the function I require. In lowercase, I'll set it true. So what it does is it will convert all characters in words to lowercase before tokenizing, as we will not be able to differentiate between uppercase and lowercase words if they come. So now stop words is English. So what this does is there's a built-in stop word list in this library. So it will use, if it identifies any stop word from that library, and then it will just stop the sentence. So max features is set to 85. So maximum 85 words will be used for prediction. These 85 words will be the words which come most of the times in that data set. So now next what I do is I create a corpus, that is collection of text. So now moving downwards, in corpus what I do is I perform fit transform for that vectorizer. What fit transform does is it will learn the vocabulary dictionary that has been created, and it will return it in terms of matrix. So then I'll be changing this matrix into array using this toArray function. Alright, so now I'll be building my model. The model I'll use is really a basic one, that is logistic regression. So now once this model is created, I'll be fitting two things in it. First is the corpus data features that contain the training data. These will be the training data values. Alright, these sentences. All the sentences will be passed in X, and in Y I'll be passing the sentiment values of these. Okay, so now going towards results. So test underscore predict. What this is a variable, and I'll be using model dot predict. Dot predict is the function. It will be predicting the value for the train. This will give the sentence that I'm passing. All right, the sentence that I'm passing through command line, that will be input here, and that the value that is predicted for that sentence is going to test predict. So in the end, I'll be just displaying the sentiment value for that text and the text itself. So I'll be showing it's working here. For example, it is Python, the code, that is my file name for my Python file, and this is the sentence. All right, so it takes some time to run. Let it. All right, so you can see here one, that means it is a positive sentence. All right, so I have optimized it even more. All right, in my site you will see here. Here, this is my page. So if I enter any text here, all right, and when I click submit, it will run, and the output is displayed here. See, positive sentence. And if I type something else, it will run on it, and the output is again displayed here. It takes some time. All right, negative sentence. So that was the negative sentence. So this is the basics of my project. This page has been created using PHP and HTML mainly, and the code is in Python. All right, so thank you very much.